right now, as well as YouTube. So if you on TikTok or Instagram, just go to our YouTube channel and you'll see everything on the screen, because otherwise you won't be able to see the screen. Uh, Unfortunately, we're not able to share the screen with you guys at this moment. So, but if you go to YouTube, preferably go to our YouTube channel, you'll be able to see it. Hey, my day is going well. I don't know what's going on TikTok. I might have to refresh this and start it over. Uh, I'll try to go.
Welcome to the business side of TikTok.
So TikTok, I had to refresh it and start it over. And if you're on Facebook or YouTube, if you go on Facebook or YouTube, you'll be able to see my screen and what I'll be talking about in a little bit. So I'll let some more people coming in. Let's see. Who else is live? Danielle, what's going on? Frank, what's up? Hey. Jade, what's up? No, I had to refresh the TikTok page. I don't know. I think people are having trouble with it. I don't think you are the only one. I just had to refresh the page. I just had to close it and refresh it again. Slow down, Buster. What's up? Who else is here? Oh, you see, you got excited. You probably was the first one when I refreshed the page. Probably. But I think there was some people here before, and then I refreshed the page, and then we got to do it again. Who else is here? Timothy, what's up? So we talked about a bunch of stuff yesterday, and I'll show you guys my screen. Four, three, -2. Who else is here? So let me know what you want me to talk about. Now you gotta give me, along with what I prepared for you guys. Let me know what you want me to talk about. Let's see. Jade, Yeet _dude, what's up? Hey, if you have any questions that you want me to talk about specifically, let me know. Man, I really wish I seen this before I finished struggling on algebra. What were you doing? What kind of work were you doing? Do you have a specific topic you want me to talk about that I didn't cover yesterday? Let me know as well. I'll be able to talk about it. Who else is here? Hey, what's up, Timothy? What's going on? TJ Bark, what's up? Polynomials, functions. Okay. Oh, I'm sorry to hear that. Were you the one who said you couldn't understand chemistry yesterday? I'm sorry that you didn't have a good score in chemistry. Jade, were you the one who said you couldn't understand chemistry yesterday? Because I know somebody said that yesterday. All right. So we got matrices, matrix multiplication. So I'm writing them as you guys are saying them to matrix. Let me see. Where's my stylus? The one I was using yesterday was really good. After chemistry, I hope it's good. Wait, you just say that you fell? I thought you had your score already. Uh, Matrix multiplication, multiplication, functions, polynomials, functions, polynomials. Maybe we'll find domains, maybe of function and range. Domain slash range. And then we'll do, I think I saw someone talking about this too yesterday. We'll do systems of equations with probably two unknowns. Systems of equations. And then that would probably conclude it for the night. If you want to see the screen, go to Facebook or YouTube. I'm about to share the screen now, so you guys can understand what I'm talking about. Hey, what's going on? Kia Maze, what's going on? So, let me put in the matrix that I want to talk about. 1, 4, negative 2, 0. 1, 4, negative 2, 0. And then times another matrix that's 2, 1, 3, negative 1. 2, 3, 1, negative 1. All right. Okay. We are officially about to start in 1 second. Thanks for sharing, Alana. Thank you for sharing. 1, 4, negative 2, 0. And 96, negative 6, negative 6, negative 4. So, all right. Cool. So let me share the screen so you guys kind of understand what I am referring to. Before, I want to make sure that entire screen. And yes. So if you go to YouTube or Facebook, you'll be able to see the screen. Let me type the link for you guys, preferably YouTube, unless you have a Facebook account. I don't think you guys do. Also, you probably have YouTube. It's the Jax Tutor on YouTube. Just go on YouTube and look for the Jax Tutor, and then it will pop up the link. And then I'll type it here for you guys as well on TikTok. Oh, I almost ended this. The Jax Tutor. Okay, so we'll officially start now. So if you go on YouTube, you'll be able to see everything that we're referring to here. So what we're going to talk about systems of equations. We're going to talk about polynomials. I don't think we talked about those yesterday. And we also will talk about some matrices, matrix multiplication or addition. And then we're probably going to do it for the night. Let me double check that we are live everywhere. Let me double check Facebook. I think I'm going to unshare my screen for a little bit just to make sure that we are live on Facebook and YouTube. And YouTube too. So if you're on Facebook, you probably tell me if I'm live. How you doing? Sky. I'm doing well. How are you? So you saw us live on YouTube. Okay. Let me see if we're live on Facebook as well. Because if not, live video. Wait a minute. I think something. Oh, wait a minute. Yeah, it is live. Back. Oh, okay. All right. So, I think we are live on Facebook as well. I don't know what's going on, but this is not showing it. Okay, there you go. Okay, cool. So now it's I think the Facebook one has a delay in it. And then I'll bring on the comments in a little bit, guys, for you. So whoever commented on here, I'll bring on the comments for you guys, so you can see them. So I just wanted to make sure that it's live on both YouTube and Facebook. Let me double check YouTube too. Yeah, it says it's live. Okay. So now I'm gonna share my screen again. Both YouTube and Facebook. Let me double check YouTube too. Yeah, it says it's live. Okay. All right. So, I don't need this. Okay, so I'm gonna share my screen again and make sure that you guys are seeing it. Yeah, I see a lot of you guys on YouTube. Cool. Share the screen. And if you're able to see the screen, let me know. You should be able to. Hey, what's up? Emmet, Michael, my, I'm not catching the name. Facebook. Elena, what's going on? Michael. Okay, so all right, so let's start with stuff that are probably simple in matrix multiplication, and if this is the first time that you see matrices, basically you can arrange numbers in terms of matrices. So you have your rows here, and also your columns. So in one dimension, if you say 2 plus 3 is 5, but also you can arrange numbers in vectors. You have a 2 and a 3 plus 6 and a negative 1. You can arrange numbers that way. You can also have them in matrices, a 2 by 2 matrix, or a 3 by 3 matrix, or a 4 by 5 matrix. So you can arrange numbers that way to represent different things. So in this case, we have two 2 by 2 matrices, and we want to know how to multiply them. So I wanna go over other stuff before we go straight into multiplication. I'm gonna go over certain stuff about basis about matrices that you probably should understand before you can understand how to multiply them. So the first thing that I want to talk about is matrices. So how do we arrange those numbers? What do we call this? So here we have the rows, and then I'm gonna move this way a little bit. Let me use the different color. So here you have the rows, matrix, rows. So let's go to matrix right here. This matrix right here. You have the rows here, and you can tell what's row. First row, second row. And then if we go this way, up and down, of course, they're going to call them the columns. So first column here, second column here. Now, this is going to be key when we multiply those matrices, because even when you're adding them too, because you want to know where each element in the matrix is. You want to know where each one of those numbers, where they are. So if it's in the first row, second row, or third row, second column, you want to know that. So the first thing I'm going to ask, some of you guys, so consider this matrix that we have up here, 1, 4, negative 2, 0. So what's the 1, 4, negative 2, 0? Tell me what's the element that's in the first row, second column. So remember I said row. So this is the first row, and I'll go slow. This is the first row. Both of these elements are part of the first row. If you think about rows, row, row, row. And then both of these elements at the bottom here are part of the second column. Second row, actually. First row, second row. Now, so that's what we find. That's how we see the rows. Now, and in terms of columns, so what do we see? So in column, you wanna go up and down. For column you go up and down. So this is the first column. This is the second column of the matrix. So now I want to know what's the element that's in a first row, second column? I think that's what I said. So what's the element that's in first row, second column? Let me see what the comment says on here. -2, Amnet, that's what Michael said, -2. Thank you. This is probably Alina. This is probably, it may be considered algebra 2, maybe. I think that's where you start seeing those things, and maybe pre-calculus too. You could probably see it. So these are like matrix operations. So what we're going to do here specifically is multiplications and additions. Guys on Instagram, I'm trying to find the best way to put this thing to sit down. Let's see. It's going all over the place. Let's see. All right, so Alina, this is matrix multiplication operation. So what we're doing here is we're gonna go first with oh shoot, I need to pay attention then. I'm in algebra 2. Yes, you may or may not see it in algebra 2. I think probably pre-calculus. I think I work with kids who were taking algebra 2. They didn't see it, but I think pre-calculus for sure you'll see matrices. Yeah, so it's pre-calculus for sure. So if you in algebra 2 where the teacher, have when they get a chance to ask, this is the question. Okay. So if you sometimes if you in algebra 2 where the teacher have a chance to go over things, that are probably not part of the regular curriculum, you'll probably see it. But pre-calculus for sure you should be able to see matrices. And so that's what we're doing here. So I'm gonna show you guys how to add them. So adding these two matrices, so we have this one here and then this one here. So when I'm adding those, so what I said, so somebody already told me what's the first row, second column. So if I want to know what's the second row, first column, what element in this matrix, and I'll write it neatly for you so you understand what's the element that's in the first row, second column, 1, 4, and 0, 2, right? Is -2, 0. The things you understand about this is each element has a coordinate. It could either be first row, second column, or second row, first column. That's the only element with that coordinate. Think about those are placements. Each one of them has a place, and there is no other element in this matrix that has this place. So there's only one element in first row, second column, as you guys already printed out. That was this. Now, what's the element that's in the second row, first column? So let me see if you guys have it on YouTube. To view the graph. So minus 15. So second row, first column. Okay? So Alina said 4. So yeah, so 4 it is. So that's what 4. So you guys starting to get it. And as I explained to you guys, this rows, think about it this way, column, think about it this way. So this is first row, and this is second row, and this is first column, second column. And that made it easy. So now what we're going to do is what most of you will see in class is how to add, if I have two matrices, how to add them together. And then after that, I'm going to show you how to multiply them together. And then the multiplication is going to be tricky, but the addition is what you would think. The way you do the addition is you say, you take each element that in the matrix, each element you add them to the corresponding element. So you can only add matrices that have the same dimensions. Now let me go on to dimensions of matrices before I do that, because that would make you guys confused. So dimension of matrix. So this matrix that we just saw was a 2 by 2 matrix. So that means 2 rows, 2 columns. So 2 by 2, there's 2 rows, and then 2 columns. So now let me see who can tell me what dimension is this matrix. And then I'll give you another one here. So what's the dimension of this matrix first? What's the dimension of this matrix? So the matrix start here. So this could be like a vector, actually. So what's the dimension of this? 2, 4, 1. And what's the dimension that we're looking for? So remember, we say the row first, multiply or by the column. So number of row by number of columns. So you know how to find rows, you know, the rows. And then the columns are, you go up and down. Rows, you go left and right. So number of rows times number of columns. So what's the dimension of this matrix right here? Alina, are you going again? Let's see. Let me see if I can find the answer on YouTube. And -2. The comments are coming fast. So who could tell me what's the dimension of this matrix? So it's some, okay, Michael said a 3 by 1. Alina says a 3 by 1. So let's see. So first row, second row, third row, that means it's a 3 row times 1 column. When you have 1 column times 1. 3 by 1. Now you're starting to get that. Let's do another one, probably 7, -3, 4, 8, 6, 5. What's the dimension of this matrix? And after that, we're going to move on to adding them. Now, the reason why I show you dimension is because so you can understand that, you know, certain matrices you cannot add them together. So what's the dimension of this matrix? So it's a 2 by 4 according to Michael. So Michael says it's a 2 by 4. So rows, 1 row, 2 rows, and then 4 columns, 1, 2, 3, and 4. So whatever Michael said, 2 by 4. Now, what if somebody said, if they wanted to add this matrix on the left to this one right here on the right? Is that possible? Yes or no? So let's see. Yes. Okay. So is it possible to add the left matrix to the right? Michael said yes. Who else? Who else got an answer? Michael said it's possible. And who else? No. Okay. SX Sphere say no. No. Mayu say no. Okay. So let's see. So when we add a matrix, here's how we do it. The way you do it, you take. So let's say you have a matrix that has 4 stuff and it's 4 elements in it. And then you have another one. The only way you can add these 2 matrices for addition, the only way you can add them if they are the same dimensions. So if they're not the same dimension, you cannot add them. Even if that by the same dimension, number of rows and columns, this is a 2 by 2. This needs to be a 2 by 2 so you can add them. So you can add them easily. So what you would do, you would add this element to this element right here. And I'll make the other ones another color so you can understand. You'll add this guy to this guy. You'll add the second one, the first row, second column, which is this element to this one. Second row, first column, you add them together. And then second row, second column, you also add them together. So that's how you add them. So the only way you can do that if the dimension of this matrix is the same as the dimension of this matrix. That's for addition. And then when we think about this too, subtraction is kind of like an addition too. So if you take in if you say, hey, this matrix minus this matrix, so what you can do is say this matrix plus the negative of the other matrix. So you multiply this other matrix by a -1, and then you just add them. So it would be the same thing. It would be a similar addition. But it's the same thing. Dimension of the one on the left needs to be the same as the dimension of the one on the right. So let's do some addition, and then we're gonna go to Jess G24. Hey, if you guys on TikTok or Instagram, if you gotta go to YouTube so you can see what's going on. So let's go to another let's add some matrices. So let's say we have one matrix. And then you guys let me know what this is. This is what you would get for this. 0, 3. That looks like a 6. That's not a negative. That's a 3. Although I could have made it a negative. I don't know why I didn't do that. Plus another matrix that's -1, 0, 4, 7. Now, how do we add those two matrices? How do we add them? What's the proper way to add them? Who can tell me? Let's see. So now we're gonna get another matrix that's gonna be, the first matrix is a 2 by 2. Whatever we're gonna add it to is a 2 by 2. That's gonna result in a matrix that's also 2 by 2. So that matrix is gonna be a 2 by 2. So just like I said earlier, we're gonna add the corresponding element. So this element right here, what looks like it is here. So it's the first row, first column, first row, first column. So 2 minus 1, and that would give you first row, first column. You cannot put this right here. Whatever I just wrote, you cannot put it right here, 2 minus 1. No, you cannot do that. So this is how you do the first one. And then you move on to this guy, the -4. You're going to add that with the 0. -4 plus 0. And tell me what number we're going to add to the 7. And I'll leave that for you guys to do. The 7, what number we're going to add to it. So -4 plus 0. And I'll do this one, 0 plus 4. 0 plus 4. And then the 7, what number we're going to add to the 7? 7 plus what number? 7 plus, and there's only one left. So 3, that's right. That's right. Mnet, that's right. 3, 7 plus 3. 7 plus 3. Nice. Okay, so that's about it. So now how do we add those? Just like you would add numbers. This 2 minus 1 is 1. -4 plus 0 is -4. 0 plus 4 is 4. 7 plus 3 is 10. And I just made these up, and it's not hard to do them. You just got to know how to do them properly. So, you guys understand? Any questions? Let's see. Elena, I don't understand the facial expression. Any questions? Any questions? Concerns? Nope, not yet. All right, cool. So now let's move on to what we started this video with. So let's go all the way back to the top. What did we start with? So we had these two matrices. We wanted to multiply them. Let me write them again. So that's what we started with. The reason why I explained all of this to you guys is because I wanted to know how to multiply these two matrices. So multiply this matrix by this one, 2, 1, 3, -1. Now, how do we add these two matrices? So how do we multiply them? The way you do this is by first. Let me go into the case of when can we multiply matrices. There are cases where you cannot multiply the matrices, just like there were cases where you cannot add them. But in multiplication, the restrictions is not as strict as in addition. What I mean by that is the matrix on the left doesn't necessarily have to look like the one on the right. But there's only one thing that you need to do is, and I'll show you a simpler way to remember this, is the number of column in the first matrix needs to be equal to the number of row in the second matrix. Now, you could try to remember this that way, or I'll show you how to do it. So you write the dimension of the first matrix. I already showed you guys how to do that, and you know how to do it. So this one is a 2 by 2. This one multiplied by, let me do this for multiplication, by another matrix that's a 2 by 2. Now, what I said earlier, the number of column in the first matrix needs to be equal to the number of row in the second matrix. Uh-oh.
Best side of TikToks.
I don't know what's going on. Wait a minute. All right, so I don't know what's going on TikTok. Yeah, I'm not sure what's going on TikTok. But okay, so what I was saying, hey, you guys, if you all on YouTube already, that may not, that may be okay for y'all. So what I was saying is the number of column in the first matrix needs to be the same as the number of row in the second matrix. So what's the number of column in the first matrix? So the number of column in the first matrix is 2, because this is row, this represents column, this represents column in the row in the second matrix, this represents column. So these two numbers in the middle just have to match. So what you would do is you write out you write out the dimension of each one of the matrices, and then you make sure that these two numbers match. So let me do it again. Let me do it again for certain matrices, for other kinds of matrices. Let's leave this page right here because we're going to come back to it. And we're going to come back to solving what we were solving for, what we started this video with. So let's say I have a matrix that's 2. So remember the middle numbers. So what you would do is you add. So what you would do is you write the dimension of each one of the matrix, and then after that you try to see which one of them match. You write the dimension of each one of the matrices, and you try to see which one of them, if the number of column in the first matrix matches the number of row in the second matrix. So let me see. Let me go back to Facebook and see what's going on. So this is. Let me put this volume down for a little bit. Okay. Hopefully, I'm not making any noise that you guys couldn't understand. So what you would do is, so let's say I have a matrix 3, 2, 2, 1, 5, 9, 6. That's the first matrix. And then I have a second matrix, 1, 7, 4. Can we multiply these two matrices? Can we multiply them? Can we multiply these two matrices? So who can tell me? Can we multiply these two, the first matrix by the second matrix? Is it possible to multiply the first matrix by the second matrix? Alana say yes. I believe so. Actually, I don't know. Okay, cool. So what we need to do is write out the dimension of the first matrix. What's the dimension of the first matrix? It's how many rows? 1, 2, 3 rows. It's a 3 by how many columns? 1, 2. It's a 3 by 2 matrix. Okay. Multiply this by another matrix that's it's a 1, 2, 3 column, 1 row, and 1, 2, 3 columns. So 1 by 3. Now remember what I said. You find a way to you list the dimension of the matrices. So of both matrices, you list the dimensions of them, and then what you do is you write out the dimensions of both matrices, and you make sure that these two middle numbers are matched. So this is a 3 row by 2 column matrix, and that one is a what? Is a 1 row by 3 column matrix. 3 by 2, 1 by 3. These two numbers in the middle don't match, so that means we cannot multiply them. So we cannot multiply them. So no, that's right. Okay, let me give you another example before we go do what we were trying to do. So let me give you another example. So let's say we have a matrix that's 4, 7, 3 by another matrix that's 3, 4, 6, 7, 9, 0, 0, 1. So can we multiply these two matrices? Are we able to multiply them? So what I would do if I were you, say, okay, what's the dimension of the first matrix? And then you list that down. What's the dimension of the second matrix? You list that down, and then see if the two numbers in the middle match. So can we multiply these two matrices? Can we multiply them? Yes, no, maybe. No, that's right. That's right. Okay. Who else? Apparently, A. Okay, so let's see. Let's see if the middle numbers, not the, oh, no. Okay, when I say the middle numbers, not this number here in the middle. I'm saying that. So what I'm saying is you write out what dimension is this? 2 by, it's not a 2. It's 1 row by 3 columns. So this is a 1 by 3 matrix. And that's what I mean by the dimension, the numbers in the middle. So the first matrix is a 1 by 3. And I'll even write this in a different color so you don't confuse it with any other numbers on the screen. So this is the dimension of the matrix. So this is a 1 by 3 matrix. And the other matrix is, so we're going to multiply this by another matrix that's a 3 by 3, 3 rows and 3 columns. 1, 2, 3, 1, 2, 3. That's a 3 by 3. Okay. Now, do these numbers in the middle match? Right? This is a 3 here. Compare that to this number. So that's what I mean by the number of column in the second matrix. See, the number of column in the second matrix have to match the number of rows in the first, and the number of column in the first matrix has to match the number of rows in the second matrix. So the number of column in this matrix have to match the number of rows in this matrix. So in this matrix right here, we have 1 by 3, 1 row, 3 column, 3 different columns. And in that matrix right here, the second matrix, we have a 3 by 3, 3 rows, 3 columns. These 3 match, so that means we can multiply them. So you guys understand? I get it. So the middle numbers with the dimensions. Yeah, that's right, Alina. That's right. Okay. Yeah. 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 So these two numbers, those two numbers match. So yeah. That's right. Cool. Now, how do we go back to what we were doing when we first started this video? We were doing something. Christina, let me reply. Go to Okay, so now let's go back to what we started this video with, which is how do we multiply these two matrices? So now here's the thing to remember to understand. So when you multiply in matrices, the thing to understand is what's the position? What exactly are we multiplying? The way this goes is so let's say this element right here is in the first row, first column. To find the element that's in the first row, first column, so what you need to do is multiply the first row of the first matrix by the first column of the second matrix. So remember, this one is in first row, first column. So this one is in row 1. So this guy right here, if I just row 1, column 1. So that's this guy right here, row 1, column 1. So how do we find the element that's in the first row, first column? So what you need to do is multiply the first row of the first matrix times the first column of the second matrix. So what's the first row of the first matrix? Is these two numbers are the first row. So we're going to multiply them by these two numbers. And it's easy to do that. So the way you do that is kind of like a dot product. You take this number right here and multiply it by this. So you take the 1 multiplied by the 2. So 1 times 2 plus, and you take the 4, you multiply it by the 1 plus 1 times 4. So first row, I need the element in the first row and the first column. So I take the first row of the first matrix times the first column of the second matrix. So what's the first column of the second matrix? First row, first column. So 1 times 2, and then 4 times 1. 4 times 1. And that gives me this element right here. I'm going to change color so you can understand exactly where those numbers are coming from. Let me go in maybe purple. That looks kind of like red, but let's go in purple. So let's go here. Let me try to find what element is here. So what's this position right here? Let me make 4 squares so you understand what the positions. What's this position? This position right here is the first row, second column. So I'm going to multiply to find the element that's in the first row, second column. I'm going to multiply the first row of the first matrix times the second column of the second matrix. So the first row of the first matrix, which is this, times the second column of the second matrix. Remember, this position is first row, second column. So first row of the first matrix times the second column of the second matrix. So who can tell me what this would equal to? So that would mean 1 times 3. 1 times 3. And then 4 times negative 4 plus 4 times negative 1, actually. Okay, so that should do it for this one. 1 times 3, 4 times negative 1. Now, what position is this? Row 2, column 1. So I'm going to take row 2 of the first matrix. I'm going to multiply that by column 1 of the second matrix. So tell me what's going to happen here. Let me do the last one, and then you guys tell me what's going to happen in this case. What numbers I need to multiply to get what's going to come here. Let me write this in green. I'll put this in green so you guys come up with the green part. Let me know what's going to go in the green part. If you could do the addition too, and tell me what it's equal to in the green part right here, the green dot, what's going to be there, that would be good. Let me see. You guys on YouTube, I know you're smart. Someone says -1. Let's see. No, that was okay. So it's 1 times 2 and 4 times 1. Okay, let's see. 1 times 2 and 4 times 1. 1 times 2. So we're in the second row. And second row. And then first column. So I'm not sure which one you enter into. That was for the first box. Okay. All right. So, all right. 1 times 2, 4 times 1. That's okay. So tell me the third box, the one in green. Tell me the third box, and I'll say the first box so you guys understand. While you tell me the third box. Actually, I'm gonna see. Yeah. Let me say the last box. Let me do it so you can tell me what's in green. What's gonna go in the green part. So let me do this one in maybe orange. Good. So the one in orange. Oh, we could use blue too. The one in orange right here. So what it's going to be is, how do we find the one in orange? The one in orange is the second row, row 2, second row, and then second column, column 2. So I'm going to take the second row of the first matrix times the second column of the second matrix. So second row, row 2, -2 times the second column. So because this is in second row, second column, I take the second row of the first matrix, I multiply that by the second columns of the second matrix. So -2 times 3 plus 0 times -1. 0 times -1. Now, let me see if you guys have the green part. Okay. The green. So -4. Someone say it's -4. I think. It's 2 times 0 and 2 times 1. Okay, let's see. I think it's -7. Never mind, it's -6. Enet says -2 times 3 plus 0 times -1. Okay, so let's see. Let's do it. Green part. This position is second row, row number 1, row number 2, second row, first column, column number 1. So how do we find the green part? Let me write it in green so you guys don't get confused. So I take the second row of the first matrix, row 1, row 2, second row of the first matrix, and I do a dot product with the first column of the second matrix. Second row, first column, -2 times. So you take this element, -2, times this element, the first element in the second column, times 2. Let me erase this so that don't look messy. Doesn't look messy. -2 times 2 and 0 times 1 plus 0 times 1. I think this should do it. All right, so -2 times 2, 0 times 1. Cool. Let's see. Let's see what we get. If we didn't make any mistake, I think we should do it. We should have all of this correct. Eraser. Let me see. Okay, so 1 times 2 is 2. 4 times 1 is 4. 2 plus 4 is 6. So 2 plus 4, I'll put 2 plus 4 in here. 2 plus 4. And purple, what do we get in purple? Can you guys tell me what's in purple? I'm gonna leave that to y'all. Let me go on to green. In green, I have 2 times -2, which is -4, 0, -4. And then in orange, you guys, I'll leave the purple for you. In orange, I have 2 times -3, -6, 0 times -1, 0, -6. And then 3 times 1 is 3. Let me see if you guys have it first. 3, -4. 3, -4. That's negative. Is that right? So what we have 6, -6, -4, -1. Is that right, guys? I think it should be good. All right, cool. Let's move on to something different. What you guys have in mind? Let's move on to something else, and then I think it might be time. We're probably gonna close it. I don't know what's going on with TikTok, but I think it's hard to go live on there now. All right, -1. That's what. That's right. Just say you got it right. That's right. Why wouldn't it be the second row of the second matrix? Which part are you referring to, Michael? Let me double check. I think we got all of them right. Let's see. So we have first row first. Okay, so let's see. Second row, second column, -6. I think this is good. Yeah, Michael, let me know what you're referring to. 3 times 1, -3 times -4. That's good. 3 times 1, -1. Okay. Yeah, I think they all are right. First, second row, first column, -2 times -1. Yeah, Michael, I'm not sure what you're referring to. -4. Yeah, I think this should be all right. Let me see. Okay. Oh, you say my chat lag. Okay. And the TikTok is the Jack's Tutor. I was on there. I don't know. The Jack's Tutor. It's the same thing as the YouTube channel. I was live on there earlier, but I don't know, something happened. All right, so let's see. Somebody say we talk a little bit about polynomials. So let's talk a little bit about that. So let's start with some simple stuff that you guys probably know. Maybe something with one term. So let's say we have a function. Oh, I forgot to use black. Not all. F of x is equal to. So let's say we have x squared plus 3x plus 6, and let's say we have something like that we one of the question, that easiest question that they might ask you if you're looking at polynomials, they might say, hey, what's the degree of this? What's the degree of this polynomial? Who can tell me what the degree of this polynomial is? And who can tell me what the degree of the polynomial is? Let's see who got me. Oops. Fraction throw me off. SX Thea. I'm gonna show you a quick way to do a second degree. Yeah, that's right. So second degree polynomial. So that means here is a second degree. And that's easy enough. So if we have x to the third, 4x squared plus 7x to the fifth, and what's the degree of this polynomial? Yeah, I will explain degree. It's Sophia. Sophia. Okay, I don't know where the x was coming from. Yeah, I'll explain degree of the polynomial a little bit. So who can tell me the degree of this? Fifth. Yes, that's right, Alina. So the degree of the polynomial Sophia is the, is the highest degree of the term with the highest degree. So this one has a degree of 5. So x to the 5th power is the highest power. So basically, this is the highest power. It doesn't really matter where it is. You see, in this case, I put the term here, but what you're looking for is the highest power. This is a power of 5. This is a power of 2. This is a power of 3. And whenever you find the highest power, you find the degree of the polynomial, and that's all it is. So if you have another polynomial, let's say you have 5x to the 6. Sophia, this is for you. X to the 8th, and Sophia, this is for you. You guys don't help her. 8x to the 3rd plus x to the 2nd plus x to the 9th, 20x to the 7th. So, Sophia, what's the degree of this polynomial? It's an elbow cup. What's the degree of this polynomial, Sophia? You might get it wrong. It's okay. That's right, 9. That's what's up. 9, Sophia. That's right. So you understand. So it's the highest power. Instagram already kicked me out, guys. Let's see. I gotta post this and then share it and then go back to Instagram and do it again. So yeah, that's the highest power that we have. The other thing that you might encounter when you're looking at polynomials too, they might ask you to find the domain, the range. Actually, you know what? I can go live on Instagram using this. My phone, maybe. They might ask you to find the domain of the function, the range. Live again. So the domain, when we think about a function here, even if we take something as simple as, let's take something simple as f of x is equal to x squared. So let's say we have that, and they ask us, hey, what's the domain of this function? So the domain is the set of all input values. And so in a function, you have a set of input, a set of output. So the input are possible values that you can put for x. So let's say the function is in terms of x. The inputs are possible values that you can put for x. And the outputs are usually y. They, by convention, normally it's y. So the outputs are f of x or y, so the possible outcome, so whenever you put a value for x, what are the possible values that the function can spit out? So those are the possible outputs. Now, in this case, if we want to find a domain, we want to find all the possible values that I can put inside of this function to say, okay, that makes sense. And the example that I normally do is kind of like an analogy, but it makes sense. I mean, think about if you have a microwave. There are certain things that you can put in a microwave. There are other things that you cannot put in a microwave, and if you put them in there, it's going to cause a fire. So, and if you think of microwave as a function, there are a set of input that are possible, that makes sense, and there are a certain of outputs that doesn't make sense, that you cannot have. And for each input, you have a different output too. You have a certain output that you can have. So let's say, and I'll give you an example. So if you think about the microwave, you can put frozen chicken in there and come out with a really warm chicken. You can put a bread, piece of bread in there, depending on how long you put it in there, but you'll come out with something that's warm. But let's say that you throw in some aluminum foil in there, and don't do that at home, it won't turn out good. So aluminum foil, if in that case, would not be considered part of the domain. because if you put it in there, it will mess something up. It will not it will not give you something that you want. It will cause fire. So domains, usually when they talk about domains, they assuming that you are in R, in the sets of real numbers. But if you include the sets of, imaginary numbers, that expands the domain. But normally they assume that you're in R. So what I'm assuming at home is I'm assuming that you don't want to cause a fire at your house. What are all sets of things that you can put inside of the microwave? Of course, not aluminum foil, not what else you could, you don't want to put gas in there or nothing like that. So you can put food, the regular stuff that you normally put in the microwave. You can put food in there. You can put, mostly food. So you can put other things in there that you can keep it in there and turn on the microwave. The same thing if you have an oven. There's certain things that you put inside, and some stuff comes out. And that's what you think about function. The set of stuff that you can put inside are what we call the domains, and the things that can come out are what we call the range of the function. And there are different ways to calculate to think about domains. So let's say if we have a function f of x is equal to 1 over x, there are certain values that you cannot put inside of this function. So you cannot all of a sudden just put 0 here. 1 over 0, that's undefined. So that's not a possible value to put inside of the function. Am I making sense to you guys? So what domain is, Willie? Is that making sense to you? So they use those terms, Alina, they use those terms. They interchange them, and normally when they talk about y, so if you write in an equation, you have y as equal to, like you guys know, mx plus b. So if you write in an equation of a line, you have y equal to that. Now, when you start talking about function, the functions, normally they use. It is, this is considered y as a function of x, because it's a function of x, because as we start putting values for x, 2, 3, 0, 9, that changes the value of y. So they call y the dependent variable, and then the x the independent variable. So each time we change x, that changes y. Now, usually what they write those when you write an equation of a line. And then you can also say, you could also argue that f of x is equal to mx plus b. You can also write it this way. So they use those terms interchangeably. So there's not, as far as you are concerned right now, normally there's not a big difference. When you write in this way, it's probably more descriptive in your case, that you say, this is a function of x. This is a function of x. So 3x. Now, the other confusion that this might cause is if you have a function, let's say I give you a function. If I say y, and then that's the confusion that this might cause. So if I say y is equal to 5x plus 6z. Now, in this case, if I don't tell you that z is a constant, you don't know if y is a function of x or if it is a function of z. Does that make sense? Am I making any sense? So in this case, you don't know if it's a function of x or if it's a function of z. Now, to be more descriptive, when you start writing function, because you can encounter terms that z, to be more descriptive, you have to write f of x is equal to 5x plus 6z. So that means what I'm changing is the value of x. That's the function is in terms of x. Or you could also write f of z is equal to 5x plus 6z. In that case, x is not a variable, it's a constant. Z is the variable that we need to change. So to avoid confusions, normally, and then to be more descriptive, you would write y, f of x is equal to f of x is equal to 5x plus something else. And then the other thing that this does, the y is equal to mx plus b equation, the other thing that this does is, it really relates back to the Cartesian graph to tells you this is the y-axis, this is the x-axis, and if I plug in a value for x, I can find a value for y. And now when you start getting into functions that have term x squared, x to the third, x to the fourth, you don't want to write is equal to x squared plus 6x. And then if you have a constant here, c, I don't know if y is a function of x or if it's a function of c. The proper way to write it, if you start having things like that, is f of x or f of c, depending on how you want to make the function. So you can use them interchangeably, but also you gotta, if it doesn't cause confusion, if it's gonna cause confusion, you're gonna have to write which one is the independent variable. And you write f of x that way. Does that make sense? So it was a long answer to your question, difference between y and f of x. But you can use them the way that you want. Okay, so all right, cool. Any questions, guys? What is for slope? I'm just looking at your comments, Sophia. Cool. I don't see any questions. No problem. No problem. All right, cool. Any other questions from you guys? It's been over an hour, about an hour and 15 minutes. And if I don't see I was in school too once, Alina. I know exactly what's going on in the chat. I know sometimes I can't believe I spent an hour about on math. We can talk about that next time because that would take probably another half hour to explain it to you. We can talk about it next time. Need the x min, x min, y min, y max scale. Like a good window to be better view. Okay, so next time maybe we can talk about that. Let me put that in the notes. So next time I'll talk about it. What else you guys would want to talk about next time? So you said you want to learn about arithmetic sequence. And next time I go live, we're going to talk about that. And hopefully you show up too. That's the thing. What else you guys want to see next time? Question: how does one know all this math? That sounds like some high math. Arithmetic sequence? Let's see. Oh, the MX thing. I'm trying to find the slope. I think you were asking for the slope. The slope is the m, is whatever is in front. Okay, point slope form of a line and parallel and perpendicular lines. Okay. Let me bring those to the screen so I can point slope form of a line, point slope form. And then parallel and perpendicular. Okay. Parallel, and perpendicular. Okay. What else? I will for sure about dividing polynomials. Okay, those long divisions, that's what you meant. Dividing polynomials. Dividing polynomials. Dividing polynomials. Polynomials. Okay. I go live for sure. Maybe summation notation. What class are you taking? MIU. I go live for sure on Tuesday. I'll be live on Tuesday. For sure. And if I'm able to come on another day before that fraction, okay. Multiplying two fractions, multiplying two with fractions. Oh, algebra 2 right now. Okay, good. Oh yeah, that's probably why you're doing the sequence stuff. Are you saying multiplying two fractions, Sophia? Multiplying two fractions? Yeah, but I'll be live for sure on Tuesday. If I'm able to come on live before that, I will let you guys know. So you can check out the YouTube channel. If I have a live schedule, I will schedule it, and then it will say it on there. I haven't done a whole lot of live promos on TikTok. I might have to start doing those. Multiplying polynomials with fractions. I would have to see an example of what you say. Multiplying polynomials with fractions. With fractions too. I don't think so. Next time I'll come when I come live next time. I will talk about those for you with you guys. So I have arithmetic sequence, point slope form, parallel and perpendicular line, dividing polynomials, and Sophia, I'm trying to get what you're saying, multiplying polynomials with fractions. Multiplying polynomials with fractions. If you have multiplying polynomials with fractions. So next time I'll come back, I'll talk about these topics. But I'll be live for sure on Tuesday, and if I'm able to come on another day before that, I'll let you guys know. And thank you all for your time. And it was nice chatting with all of you. And I look forward to the next time to go live and helping you guys. Thank you very much.